Okay, tonight I asked you to do problems 1, 3, 6, and 9. So we're going to take a look at problem number 1. It says yellow light given off by a sodium vapor lamp used for public lighting has a wavelength of about 600 nanometers. And they want to know the frequency of that radiation. So we're going to compare wavelength to frequency. So we're going to use that little constant, 3 times 10 to the 8th meters. There is a frequency of 1 hertz. Okay, well, 600 nanometers. I know that a nano is 10 to the negative 9th, so I could say for every 600 times 10 to the negative 9th meters, there is a frequency of blank hertz. All right, and I know that the relationship between wavelength and frequency is inverse. So this is going to be times 200, and I got to lose zeros. I got to get from 8 to negative 9, so this is times 10 to the negative 17th. And on this side, I'm going to divide by 200 times 10 to the negative 17th. So 1 over 200, well, 1 over 2 is 0.5, so 1 over 200 is 0.005 times 10 to the, well, this is negative 17, but I'm dividing by a number less than 1, so then it's going to turn to positive 17. And if you think about this, I'm going to take this number and I'm going to bring it out. I'm going to bring it out 17 and come back 15. Oh, I'm going to come back 14. So this is going to be 5 times 10 to the 14th hertz. Now, you may have solved that a little bit differently, but somewhere around the same. Okay, and then question number 3 says to calculate the energy of 1 photon. This is the wavelength of that 1 photon of the yellow light. Oops, sorry about that. Of the yellow light that has a wavelength of 600 nanometers. Well, that's the same thing that we had before. So now we just want to calculate the energy. And I know that energy calculation is right here. And I know the relationship between energy and frequency is direct. So, and we talked about that when we did the lab. We said, look, it takes, if we walk with smaller wavelengths, it takes more energy, or the smaller frequencies, if we walk with smaller steps. Okay, so we're going to go ahead and let's make a box. And I know that the hertz, so for every 1 hertz, there is 6.63 times 10 to the negative 34th joules of energy. And we don't have 1, we've got, let's see, what is it? 5 times 10 to the 14th hertz. There is blank joules of energy. So I'm going to multiply by 5 times 10 to the 14th. And over here, I'm going to also multiply by 5 times 10 to the 14th. So this is going to come out to be about 33 times 10 to the, well, we're gaining 14 places, so this is 20th joules of energy. Negative 20th, sorry about that. So still a small number, but it's only 1 photon, so it's 1 small piece. Okay, I kind of screwed up giving you number 6, because you had to do number 5 to know how much more. But let's try to figure this one out just by how much energy do they carry. So it says UVB causes more sunburn. UVB photon travels at 1 times 10 to the 15th hertz. And we know that has a certain amount of joules of energy. And we know from our handy-dandy chart that the constant is that if we have just something that is 1 big wavelength, so it's just 1 frequency, it's 6.63 times 10 to the negative 34th joules. So this one's a lot more hertz, 1 times 10 to the 15th. And the relationship between energy and frequency is direct. So this is going to be times 1 times 10 to the 15th It's very similar to the last problem that we did. This is going to be 6.63 times 10 to the negative 19th joules. Okay, and then the last problem is number 8. I know that one of the classes I said to do number 9, but that one's a little rough. So let's try number 8 here real quick. So a dental x-ray has a frequency of about 3 times 10 to the 19th hertz. And we want to know the wavelength. Blank meters. Okay, so 3 times 10 to the 19th hertz. Well, I know the relationship, let's scroll back up here, between these two things is that for every 3 times 10 to the 8th, oops, wrong spot. For every 1 hertz, there is 3 times 10 to the 8th. Oh boy. 3 times 10 to the 8th meters. Okay. Okay, so now I'm going to go up to here, and I'm going to say this is times 3 times 10 to the 19th. But I know that the relationship between wavelength and frequency is inverse. So this is going to be divided by 3 times 10 to the 19th. So again, think about it this way. I've got a small number divided by a big number. That better be a fraction of 1. Okay? So 3 divided by 3 is 1 times, and this is where the fraction comes in. At 10 to the 8th, I've got 1 followed by 8 zeros. Divided by 1 followed by 19 zeros. So by doing that, I get these 8 zeros drop out, and then of those 19, 11 are left. So this is 1 times 10 to the negative 11th, or 0.00000000000. I think that's right, 0.1. So it is definitely a fraction of 1. And we know that this is right. We can kind of come back over here and check, like, what should have happened? Well, this went way up, which meant that this went way down. And that's what we proved experimentally in class. I hope that helps. I'll see you guys tomorrow.